All right, so here are some motion diagrams. So the object is moving from left to right in every case. And so these circles represent the dots that I drew earlier, but they're equal time intervals apart. And we're going to look for which one we're interested in, which ones have the greatest velocity in the last time interval. They've given us a coordinate system. They're saying, let's see. Yeah, every one of these sort of to the right is positive. So if it's moving to the right, it has a positive velocity. If it's moving to the left, it has a negative velocity. Positive numbers are greater than negative numbers. So we're looking for a ranking based on the final velocity, the velocity during the last time interval. Everybody agrees with one of those, either the top one or the bottom ranking? Any others I need to add to my list? Okay, A, D, and F. So we all agree with what? Do we all agree with this? We can cross off the first one. We okay with that? Okay. How about the last part? It's a little hard to tell on this. It looks like C is actually touching. The last two looks like they're actually touching. And B and E look like there's a tiny gap between them. It's a little hard to tell. I guess I would accept this one, or B and E being greater than C. Either one of those I think would be okay. It's a little hard to tell on this whether those, on C, whether those are touching or whether it's the same gap as B and C. Okay? We good with that? Should we look at acceleration now? So now we want to rank these based on the acceleration. We'll assume that these all are undergoing constant acceleration. We'll call that our positive direction. Is there acceleration? Yes. In what direction? It's a vector quantity, right? Has a direction associated with it. To the right. You can always do a change in, you can always do a little vector addition to figure that out. Acceleration, change in velocity over change in time. So the velocity, in one time interval here, the velocity goes from, let's see, I'll use blue and green or something. That's V4. That's V3. So the change in velocity is V4 minus V3, which would put us at this. Minus V3 is this. And so what is our acceleration? Our acceleration points to the right. Because it's that divided by the time interval. Right? You kind of follow what I'm doing there? Some vector addition. final velocity minus the initial velocity. In this case, the final velocity is bigger. So when we subtract the initial velocity, we still have a vector pointing to the right. That little red vector there is pointing to the right. Okay? So the acceleration is pointing to the right. And we said to the right is our positive direction. So in this case, acceleration is positive. Okay, because we define that as our positive direction. Okay? We good with that? Now let's answer the question here. Which one biggest positive acceleration? All of them, A, D, and F? They're all accelerating to the right, right? As they move to the right, the spacing gets bigger and bigger, and that's our positive direction, so they all have a big positive acceleration. How about B and E? They're 0, and C is negative, right? The acceleration is pointing to the left, but to the right is positive, so that's a negative. Okay, important point. Another problem with acceleration. People like to think positive acceleration means the speed is increasing, negative acceleration means the speed is decreasing. Wrong. Acceleration, positive and negative, has nothing to do with the speed increasing or decreasing. It just tells us whether the acceleration is pointing in our positive direction that we've defined according to our axis, according to our coordinate system, or whether it's pointing in the negative direction. You can call to the right positive, you can call to the left positive, you can call up positive, you can call down positive, you can call any direction you want to be positive. Whether acceleration is pointing in that direction or not is just a matter of your choice of coordinate system. So as an example with this one, our object was moving to the right. We called that our positive direction. Acceleration was positive because it was pointing to the right. What tells us whether the speed is increasing is if the acceleration and the velocity have the same sign. Okay? If they're both pointing in the same direction, the speed increases. In this case, velocity was pointing to the right, acceleration was pointing to the right, so the velocity is going to increase in magnitude. The speed's going to increase. C, the acceleration was pointing to the left, but the particle was moving to the right. They're pointing in opposite directions. They have opposite signs. The acceleration was negative in that case. The velocity was positive, so the speed was decreasing. C is slowing down. Okay? So we could, you think about throwing something up in the air. What direction do you want to be positive? Up? Let's make up positive. What direction is the acceleration when we throw something up in the air? It's towards the center of the earth, right? Gravity is pulling on this towards the center of the earth. So the acceleration is down. My velocity initially is up. I'm going to throw it up, right? It's going to, as soon as I let go of it, it's got velocity in the upward direction, but acceleration is down, right? We could call up positive, we could call down positive, it doesn't matter. We know the velocity and the acceleration are in opposite directions, so the speed has to be decreasing because acceleration and velocity are opposite directions. They have opposite signs. No matter what direction we pick as positive, they have opposite signs, right? So on the way up, the speed is slowing down, slowing down, slowing down until it gets to the top. when the speed goes to 0, and then it starts to come down. When it's coming down, its velocity is down. The acceleration is still down, right? Gravity is still pulling it towards the center of Earth. Now they're in the same direction. When they're in the same direction, what happens to the speed? Speed increases, and it increases in speed all the way down, right? It decreases on the way up, and it increases on the way down. You've done the experiment for yourself at home. You can do it for yourself later also, but that's just an example of that. You got to get used to thinking not the sign of the acceleration, but whether it's pointing in the same direction as the velocity or the opposite direction is to tell you whether the speed is increasing or not. Yeah, if I just said there's an object here, and there's an object at time 0, the object has this position, and the acceleration is down, and I ask you to describe the motion after that, well, you don't have enough information. You have to know something else about it. You have to know what its initial velocity is. If it's at rest and the acceleration is down, then it's going to start moving down with increasing speed, right? If it was moving up at this instant, then it's going to keep moving up, but it's going to slow down, slow down, slow down because the acceleration's in the opposite rate. Yeah, you'd have to know what the initial velocity was.